periodic webinars. We're still waiting to come back live. My name is Dean Case. I am the Vice Chair for Membership. We had a few little technical snafus. Mike Guidry, our section chair, is trying to log on, so we may have a few words from him as well. But before we get to our featured speaker, just a few announcements of upcoming events. SAE International is hosting Aerotech, which is a conference in Pasadena next week, March 15th through the 17th. Go to sae.org if you'd like more information on that. There'll be some student activities in conjunction with that. And that's one of the first large SAE events that will be face-to-face. So hopefully we get a good turnout for that. March 30th will be another webinar, ADAS related. The details of that will be posted shortly. We have one student design competition this year in Southern California. That is Aero Design, and that will be in Van Nuys. And if they are looking for volunteers, look out for an email from Ryan Reynolds, who's a engineering manager at Lockheed Skunk Works and the lead person organizing that. After a 2-year absence due to COVID, we will be back at the Acura Grand Prix of Long Beach with the Stand 21 Safety Foundation seminar. So that is an excellent opportunity for all of our Formula SAE students and Baja SAE students to learn about motorsport safety topics. Great, everyone's welcome. You have to have a ticket to the Grand Prix, and we will have a link going out for discount tickets for the Grand Prix as well. And we're going to kick off our first big face-to-face event, April 23rd, in conjunction with our friends over at SEMA. We're going to be doing a showcase for student projects at the SEMA Garage in Diamond Bar. And what that will entail is, since we don't have a competition here for Formula Baja locally this year, we're going to do our best to help support our student groups and let them, if they would like to do a practice presentation for their design review or business presentation, put them through a tech inspection. But most importantly, we've got a number of companies who are actively hiring for automotive engineering positions here in Southern California. So it'll be a great place for student engineering members as well as professionals to come out. For the senior members, come out and give some nice, useful constructive critique of the student projects. If you're looking to hire or looking for a new career opportunity, show up there. I see Mike Guidry did join us. Mike, if you want to turn on your microphone, any words of wisdom before we turn it over to Cecilia Chen?
No, I appreciate you covering the opening for me. Yeah, a little trouble getting logged in, but you covered it well, and I'm really excited to get back to face-to-face and seeing all the members again. So I hope you enjoyed tonight's presentation. Thank you.
So thanks, Mike. I will stop the screen share here, but we'll put those up again at the end. But those are the main websites to take a look at. Take a look at sasocal.org. And if you notice, we don't have everything populated like we'd like to. We could really use some additional volunteers on the communication side. Everything we do here on these webinars and our guest speakers and things we do to students is all 100% volunteer. And the only way we can do this is kind of expand the base of operations with more people who would like to get involved. If you're looking to hire, there's no better way to get involved on the student activities committee to meet the future superstars of the industry. So take a look at any of these places. If you missed part of tonight's presentation, if you have to log off early, it will be YouTube archived on the SAE SoCal YouTube page. So without any further ado, I'd like to turn it over to Cecilia Chen, who is on our meetings and tours committee, and she will introduce tonight's speaker.
Well, thank you, Dean and Mike, for that warm welcome and the preview of SAE events to come. Welcome in again, everyone, to SAE Southern California. My name is Cecilia Chang, and I will be your moderator for tonight's session, where we'll be exploring commercial fleet engineering trends and technologies, state of sustainable fleets. We're excited to be joined tonight by seasoned subject matter expert in this field, Patrick Couch, who is the Senior Vice President of Technical Services at Gladstein, Neandros and Associates, also called GNA. GNA leads market development for advanced transportation technologies and clean fuels. Hello, Patrick, and welcome to a tech session with SAE.
Thanks, Cecilia. I will go ahead and dive in unless there's anything else we need to take care of at the top here. But as Cecilia said, my name is Patrick Couch. I lead our technical team at GNA. It's basically our group of engineers that works on the clean transportation space. And what do we do in that space? Well, we do a lot, right? We really cover the beginning to end and all the pieces in between for helping fleets, particularly commercial, public and private fleets, navigate that transition from traditional fuels to alternative fuels. So you'll see there, one of our number one things that we do is clean fleet strategy. We spend a lot of time day in, day out, sitting down with fleets, understanding their needs, their goals, their challenges around clean transportation, and helping advise them and helping them try to reach those goals with the technologies that are best suited to them. So what you will see tonight is a summary of a study that we prepare annually called State of Sustainable Fleets. And that builds on a lot of those relationships that we have with fleets to try to really get down to the fundamental customer level of how these different technologies are being received by the end users. We also have a very substantial creative and events presence in clean transportation. Our headline show, which is coming up in May, is ACT Expo. I think last year we had over 5,000 attendees at that show. This year will probably be bigger. We literally have, without any sort of exaggeration here, the best concentration and breadth of zero and near zero emission alternative fuel technologies for the on-road space, particularly around fleets in North America. I'm not sure you will find a better example of the breadth of the different technologies in the commercial fleet space than at ACT Expo. So if you're interested in what you hear tonight, or you're interested in the space in general, I strongly encourage you to look at attending ACT Expo later this year. We do a lot of other stuff. I won't go into all of the details on the other things we do. Certainly finding funding for folks is important because, as you'll see, I think in the presentation tonight, a lot of this technology still costs quite a bit, right? So we have to try to help bridge those gaps. Policy and regulation is pushing a lot of the deployments that we see, and the market receptivity and sustainability strategies that fleets and others are adopting are equally contributing to the push towards zero and near zero emissions. So who do we work with? As I said, most of our clients are fleets. They're our biggest part of our business, but we really work with everybody in the clean transportation industry and across all stakeholder groups. Some samples of some of our clients there, but that's important to us trying to develop the kinds of reports that you see today. So what is State of Sustainable Fleets? This is a report that is funded by the title sponsors are Penske, Shell, and Daimler. And this came out of a recognition that so much is happening in the fleet space around clean transportation. There's so many different technologies. There's so many different use cases and so many different experiences out there with these fuels, that there was no one industry resource where the average fleet operator could go read about what was happening and come away with some sense of the direction of the market. So that's what this report intends to do. The one I'm presenting to you is our second iteration of the report. It's our second year. Our third year is coming up shortly. So what was in the 21 assessment? Well, we covered a pretty broad range of fuels: CNG, propane, battery electric, hydrogen fuel cell, as well as efficiency improvements for diesel and gasoline and drop-in fuels. So drop-in fuels being renewable diesel or diesel biodiesel blends. We looked at a number of different fleet types, some of the big ones being regional haul, long haul, delivery, and utility. Ultimately, we ended up collecting survey data from over 400 fleets. We've looked at over 7 years of vehicle sales data in preparing the report. and looked at up to 15 years of fuel costs and station count information. Our goal again is to get to what are the big trends and headlines in the industry, and we prepared a number of mini guides. So if you're only interested in a particular fuel, you don't have to read through the entire report. You can jump straight to the propane or the CNG or the battery electric mini guides and just look at those to get sort of a distilled report out on those technologies. The fleet survey is a really important part of it, as I had mentioned, and we really like going to the fleets and asking them, what are you seeing in practice, right? We want to get past the marketing, past the press releases, and try to understand how it's really playing out at the ground level. I mentioned that our update, this is the 2021 report, we'll be releasing a new version of this report for 2022. That's going to be released at ACT Expo in May. So again, if you're interested in what you see here and you want to get the information first, go ahead and look at attending ACT Expo. The 2022 survey is very similar to 21, although we're making some important adjustments. One of the big adjustments that I see is including a new segment focused on environmental sustainability goals and science-based targets. So these are big emerging drivers that some of the largest fleets and companies in the world are making commitments to science-based targets. For those of you who don't understand or haven't heard that term, essentially science-based targets are asking fleets to figure out what they need to do to commit to GHG reductions sufficient to achieve the 1.5 degree C global warming limit set by the IPCC. So that's the goal. These end up being, in almost all cases, extremely aggressive goals with respect to GHG reductions. And it's just a really big topic and motivator emerging in the sector. So we're going to capture that in our 2022 update. We're also adding some optional segments for consideration around autonomous vehicles. A lot of interest from fleets there based on the potential to reduce costs and improve efficiencies. And so that's something we want to try to capture in the 2022 update as well. So let's go ahead and jump into the results from the 21 survey. And let's look, what are the headline takeaways? I think in 21, we couldn't have really talked about that year without talking about the huge growth in orders that we were seeing for both natural gas and battery electric vehicles, particularly in the class 3 through 8 vehicle space. There's a lot of press, a lot of activity around that, a lot of orders placed, and we'll get to it later, not necessarily all of those vehicles being delivered. 83% of the fleets that we surveyed were already using some alternative fuel and plan to increase the deployment of clean technologies in their fleets. So we're talking to the folks that are doing this, and they are all recognizing that whether their path has been smooth or not, they have to stay on the clean transportation path and do more. Clean fuels in terms of total cost of ownership and fuel savings. When we talk about mature technologies like compressed natural gas or propane in the sectors where they're commonly used today, they produce better total cost of ownership than gasoline or diesel. We've added this comment in here about mature technologies because you don't necessarily see that with some of the other emerging technologies in these sectors. So battery electric and fuel cell have tremendous promise, but they're not really yet demonstrating lower costs of ownership. Battery electric vehicles are on an incredible growth trajectory. They may become the leading clean fleet technology in the next 3 to 5 years. There's tremendous amounts of money flowing in, both government money and venture capital flowing into battery electric, not only in the consumer market, but also in the fleet market. And we're seeing a lot of interest and orders for these vehicles. So we can reasonably expect that battery electric will become the dominant clean fleet technology in terms of deployments in the next 3 to 5 years. Big investments and a lot of interest in fuel cell technology. I will say that when we host webinars, when we offer information regarding hydrogen, those activities generate some of the highest levels of interest from our customers and our attendees. Just an incredible thirst for knowledge around fuel cell. Sustainability commitments, as I mentioned, especially with ESG and science-based targets, are really important, becoming even more important, especially as some of these publicly traded companies, investor groups are demanding that companies take these sorts of goals seriously. So let's move on and start talking about the individual fuels and just highlight some of the takeaways that we had for these different categories. Diesel and gasoline. Clearly, they are the dominant fuel today. They're not going to just vanish off the face of the earth in the next few years. And even though a number of the light duty manufacturers have said, look, we're not going to invest any more money in combustion engines, we still see some investment in improving fuel economies in these engines. So Detroit Diesel's 15-liter engine had a 3% increase in fuel economy. Cummins engines improved about 4 to 5%. These seem like small numbers. They're obviously improvements over very mature technologies, but they're also in engines that are consuming 10, 15, 20,000 gallons of fuel a year. So when you apply those smaller percentages to that big number, it's a meaningful cost and GHG savings. We're also seeing continued growth in efficiency improvements. So Shell's Starship is kind of their showcase vehicle platform to test out all these different efficiency strategies. They got almost 11 miles per gallon on a heavy-duty Class 8 truck, which is it's basically realizing the DOE Super Truck project goals. So one of the nice things is that many of the technologies that they're demonstrating on that platform are equally applicable to other technologies. While the combustion technologies may be specific to diesel or limited to diesel and other combustion technologies, aerodynamics, smart routing, things like that can be applied to all of the different alternative fuel platforms and improve costs and efficiencies for everyone. One of the big stories, and we're seeing that story get even bigger over the last 12 months, is the growth of renewable diesel. If you don't know what renewable diesel is, it's diesel fuel that's produced from a biomass feedstock. So you might take tallow oil and put it in a hydrotreatment process, very similar to traditional diesel production. And what you produce is a biofuel that meets the same ASTM specifications as diesel fuel. And so you're able to drop that directly in to your diesel fleet without really having to change much, if anything. For that reason, it's seen as a very important near-term GHG reduction strategy. So where you can get the fuel, where you can afford the incremental cost of the fuel, it is a very compelling option for you. And then we have biodiesel, growth in biodiesel blends. Biodiesel has a challenge. When you're over about 20% blend by volume, it increases NOx emissions from the engine. And you also have engine manufacturers concerned about impacts to things like lubricity of the fuel, which increase engine wear and injector wear. And so typically biodiesel blends have been limited in their blend levels, but it turns out that blending it with with renewable diesel, which can reduce NOx emissions and potentially provide some additional lubricity, can offset some of those concerns. So you can start blending biodiesel, which may be more broadly available, with renewable diesel to get these blends that sort of stretch the supply of renewable diesel. On propane, and you'll see for the rest of these slides, you'll see that we have this sort of rough order of magnitude scale of vehicle deployments by different vehicle vocation. Propane has traditionally been deployed in what I would call the lighter side of heavy duty, right? You typically don't see these in big over-the-road trucks, but everything from municipal box trucks, utility trucks, some of the light transit vans and school buses. These are very common applications for propane. It's a mature technology. It's been around for many years. And when we surveyed the fleets, what you'll see down here, what are the fleets saying about propane? TCO, maintenance costs, fuel costs in particular. These are all things where propane is at least as good as gasoline or diesel, if not better. Where are the challenges? Vehicle costs. The propane, like pretty much every one of these technologies, has a modest to significant incremental cost, hopefully offset by your fuel cost savings, right, and your maintenance cost savings. That's why the TCO, the total cost of ownership, is better for propane than gasoline or diesel. There are some range reductions typically. A gallon of gasoline is volumetrically less energy dense than a gallon of gasoline or diesel, and the storage tanks are a bit bulkier. And then vehicle availability. You don't find propane available on every make or model or body type that you might be interested in. So where it's applicable, where it fits your duty cycles, it's going to be a really good, compelling option. And it's available as what we call near zero. I've used that term a couple of times. What that means is that it has substantially less, up to 90% less NOx emissions from the engine than the diesel standard. And one of the things that happened in 2020, which was really sort of a landmark for propane, was the first volumes of renewable propane. Where do we get renewable propane? It turns out it's a co-product of refining renewable diesel. So you can actually pull off that propane that comes off when you're hydrotreating your renewable diesel feedstock and refine that into renewable propane and use that for transportation. So we're starting to see some projects like the AmeriGas project, working with a Cummins platform to try to push propane into heavier weight classes. In fact, there was a recent announcement by Cummins that they have a tri-fuel engine that will burn natural gas, propane, and hydrogen. Not all at the same time. You have to pick which version, but that will be in a 15-liter class engine. And that's a pretty interesting development because propane has generally never had access to that market in that size category. CNG, again, you can see the scale up here. We're talking tens of thousands to thousands, so substantial number of vehicle deployments. These are mature technologies. Natural gas is very commonly seen in refuse, transit, and long haul and regional haul, Class 8 semi-tractors. But we also see it in some of the smaller weight class applications as well. Fuel supply is usually not an issue, right? We have natural gas pipeline infrastructure all over the country. So fuel supply is pretty easy in most cases for CNG. Fuel costs are almost always better. And obviously reduced emissions and all of those sorts of things while you're doing this, right? Some of the challenges, again, these vehicles cost more than a traditional gasoline or diesel vehicle. And depending on your maintenance costs, depending on your application, you can have a TCO that's similar, sometimes worse. I would say In applications like refuse and transit, usually the TCO is substantially better. But in some of the lighter applications where you're not burning a lot of fuel and therefore you're not getting a lot of cost reduction from the lower cost of the natural gas, TCO can be a little bit more challenging because of that upfront incremental cost. But I also want to call out one thing here. So we talk about CNG/RNG. RNG here means renewable natural gas. Renewable natural gas is just natural gas that's produced from renewable feedstocks. So this would be things like methane from landfills or anaerobic digesters or dairy waste, right? These things, when that organic matter decomposes, it releases methane. You can capture that, clean it up, put it in a pipeline or put it directly into a vehicle. And that renewable natural gas has some very substantial GHG benefits versus just letting that stuff go into the atmosphere. So one, and I think related to that, one thing I want to call out is this last number on this slide. At the end of 2020, 98% of all of the CNG used in California for transportation was actually renewable natural gas. That number is slightly higher. It's pretty close to 100 at this point. And so much of that gas is coming from things like capturing methane from dairy manure, things that today, without capturing it, are just releasing methane into the atmosphere, something that is a very potent greenhouse gas. When you account for the benefit of that, it turns out that the average CNG dispensed in California today is actually carbon negative, substantially carbon negative, probably 125% or more GHG reduction versus diesel fuel. So it's a very interesting trend in California that is being driven by a lot of these dairy gas and anaerobic digester projects that capture food waste, that it has to be diverted from landfills. So a nice and important climate strategy for CNG. Okay, so probably the technology that gets most of the airtime and most of the attention is battery electric, right? We see it every day in on-road, in light-duty vehicles. We all have tons of experience with batteries in our lives, and so it feels very close and understandable to us. In the heavy-duty space, battery electric is still an emerging technology. It is a technology that I think is performing pretty darn well at the early levels of deployment. The sectors that are the furthest ahead, it's really transit and to some extent school bus. Why? Regulation pushed transit faster. And there was a bunch of grant money from government to help fund the initial costs of those vehicles. But like you'll see with fuel cell as well, whenever you have an electrified drivetrain, drivers tend to really enjoy the vehicle, right? Lower noise, better torque, generally happier drivers, generally lower maintenance costs. In the case of battery electric, you also get better fuel costs, more generally speaking. The challenges right now, vehicle costs. These vehicles are, especially in the class 7-8 category, substantially more expensive than diesel or gasoline, on the order of 2 to 3 times more expensive. The range is certainly generally seen as a limitation, or at least less than gasoline or diesel. In some vocations applications, that range is less, but it doesn't actually matter to the vocation. So while it's less, it's not always a barrier. And then vehicle availability. The reality is that if you were to look at a Class 8 truck like you see on the screen there, these are all just now emerging into availability for commercial orders. And so there's fairly limited availability in terms of configurations and model choices and whatnot. That's improving over time, But those continue to be some of the challenges that battery electric faces today. One thing that's not on here that I think will probably be called out more in the 2022 study is the challenge around charging infrastructure and availability of that. So that's another big question around battery electric when you get into some of the more difficult vocations to electrify. That said, we saw in 2020 that there were 3 times more orders for battery electric vehicles than there were deliveries, right? So that's indicating a few things. 1, tremendous interest in the technology. 2, supply chains are still trying to catch up with that interest. And we see that obviously everybody's dealing with supply chain issues in one way or another today. And that certainly battery electric technologies are not immune to that. In fact, because a lot of these technologies are developing for medium and heavy duty, those supply chains are just not in place at this point, and they're maturing. That said, there's a ton of money flowing into building them out, and we're seeing a lot of progress there. One of the other things that I think is worth calling out is this last number: 96% of fleets that we surveyed that have used battery electric vehicles are installing their own private charging infrastructure. There is little, if any, public access charging infrastructure in the country that supports heavy duty battery electric vehicles, whether it's charging rate, charging voltage, basic access, cable lengths. These sites were built to serve light duty passenger cars, not to serve heavy duty vehicles. And so for the time being, most of the infrastructure out there is going to be private. We're seeing a lot of money flowing into building some of the first public access heavy duty charging stations out there. There will be some stations that look basically like electric truck stops in the next couple of years. And it'll be really interesting to see how the market reacts to those offerings. And then fuel cell vehicles, sort of the other zero emission technology. Fuel cells have historically been somewhat behind battery electric in terms of commercial penetration. The fuel cell community itself will sort of describe fuel cells as following the same adoption curve as battery electric, but delayed by about 5 to 7 years. And so when we look at these deployments, you can see we're looking at dozens of deployments. Transit has certainly been the leader, and fuel cells have acquitted themselves pretty well in those applications. But we're now seeing a lot of development and investment from OEMs in fuel cells for regional and long haul. Sort of the conventional wisdom is that where battery electric has its biggest challenges are in high daily use, high daily energy, long range, weight sensitive applications, and that's where fuel cell potentially has its advantages. So, whether it's Toyota through its Hino subsidiary, Hyundai, or some of the new market entrants like Nikola and Hyzon, we have a number of fuel cell Class 8 truck platforms that are actively being demonstrated in California today, with the expectation to bring these technologies to market in the 2024-ish timeframe. So a lot of development going on here, even though we're currently at fairly low levels of deployment for these vehicles. So one of the things when we look at the fleet's perspective on these vehicles, you'll see that the equal or better categories are almost identical to battery electric, and the adoption challenges are almost identical. What's different is that range is seen as an advantage for fuel cell, and fuel cost is a disadvantage, and that's the exact opposite for battery electric. That's what we see as the perceived trade-off at this point. fuel cells have better range and more operational versatility, but the fuel is really expensive. And electric has a lower fuel cost, but it has more operational constraints. Some couple things to call attention to here. I mentioned there were a number of OEMs announcing new product. We went from a very small number to a less small number. So we had about a 2x growth, but there has been more growth since 21. And I think you'll see a number of additional models available or in the process of commercialization in the 22 report. I mentioned fuel costs are really high. And part of that is the capital cost associated with the station. And the experience that we have in the light duty market is based on a range of generations of stations. Generation 1, 2, 3. We're now in our third and fourth generation stations. And as those stations have evolved, they've dramatically reduced the capital cost relative to the performance of that station. So station may cost the same as a prior station, but it can do twice as much in terms of dispensing fuel throughput. And so that's the kind of trajectory we need to get those very high fuel costs down. And then, of course, we're continuing to see investment in the heavy duty station infrastructure, not just light duty, because as I had mentioned previously with respect to battery electric, you can't assume that a heavy duty vehicle can use a light duty station. And so we're seeing more investment at the state level from California in developing heavy duty capable fueling stations. So that's sort of the highlights from the different fuel sectors. I wanted to just end on one quick comment because I talked about the importance of regulation driving these technologies, and I wanted to maybe just flag some of what I think are the most important impactful regulations. So California, of course, is leading the charge, if you will, when it comes to regulation and around zero and near zero emissions and low carbon fuels. All of the things you see here bolded have already been adopted and are in force in one way or another. The ICT, the Innovative Clean Transit Rule, it requires transit fleets in California to begin buying zero emission buses. The Advanced Clean Trucks Rule requires manufacturers to begin selling a certain percentage of their annual sales in California as zero emission. The Low NOx Omnibus is a set of emission standards that apply to all new combustion-based technology engines certified in California, and is going to ratchet down the allowed NOx emissions from these engines between now and 2027. And at the same time, we'll be requiring extended warranties and achieving those NOx emissions on low load test cycles, which are traditionally difficult for diesel engines to achieve because of their use of SCR after treatment systems. And then we have the low carbon fuel standard, which basically puts for every gallon of traditional gasoline and diesel sold, the importer or producer of that fuel generates a deficit, and they have to offset those deficits with credits. It's the alternative fuels, the low carbon fuels, that generate those, and you can then sell those credits to the refiners and importers. And that is actually a very substantial revenue stream for a number of these technologies, particularly electric and fuel cell, and is seen as a really important sort of short-term or near-term anyway revenue source to help try to balance out those total cost of ownership challenges. So that's what's going on in California. EPA obviously has the EPA Phase 2 regulation for GHGs. It's been in effect for a number of years, and it's slowly ratcheting up its stringency. Should be fully phased in by 2027, I believe. But they've now proposed the Clean Trucks Plan, which basically looks a lot like the low NOx omnibus plan for California. So depending on how it's adopted, you could be looking at requiring current diesel engines in 2027 or 2031 to be 70 to 90% cleaner on NOx than the current 2010 or 2014, depending on how you want to count it, diesel standard. And that is a huge challenge for diesel engines. I don't think there's any other way to say it. It's not clear that diesel can meet those standards. And so that's not that far out when you're talking about whether or not you're going to be allowed to sell diesel engines in the United States. So it's an important one to watch. And then we have Washington and Oregon adopting low carbon fuel standards following California. And because California is special in the Clean Air Act, there are 14 other states in the country that have adopted California's zero emission vehicle standards. And that includes the ACT in most cases. So we're starting to see these rules generally spread from California to a number of other states in the union. And so it is clear, I think, if you add up all of the timing and impact from all of these regulations, that between now and 2030, and really only 8 years, we're going to see a tremendous shift in what's allowed to be sold, what's required to be sold, and the costs of selling those different technologies. And so we're going to see even more interest and focus in zero emission vehicles in the next 8 years. No question about it. Okay, so that's it for me in terms of presentation. I'm more than happy to answer any questions I can. I know I'm talking to a bunch of engineers. I'm an engineer. I will try to answer your question. And if I don't know the answer, I'll just tell you. But if you want a copy of this or a copy of the 21 report, any of those mini guides, or you want to check when the 2022 version comes out, you can go to stateofsustainablefleets.com. The report should be up there for you to download. And with that, I will stop and hand it back to Cecilia.
Well, thanks, Patrick. That was a lot that we covered in a short amount of time. So since your last slide was covering a lot of policies and regulations, typically not the most interesting, but you did make it very interesting. What policies and regulations are driving that transition to low zero emission technologies in on-road fleets?
Yeah, I mean, I think it's California's ACT and ICT regulations. Those are the ones that are active now. The ICT forces transit agencies to buy zero emission vehicles, right? So that automatically creates a market. California is probably 10 to 15% of the entire US vehicle market. So it's big enough that when you say to a manufacturer, you must do this or you will not be allowed to participate in this market, it forces them to make investment. I think you're also seeing them recognize that this is aligning with other regulations that they're facing in Europe and are likely going to be facing in Asia. And so there's just this recognition that this is a global transition. And while California is pushing and kind of at the tip of the spear in many cases, they're just going to have to figure this out or get cut out of the market. So ACT, ICT are certainly really important. And I think the low NOx omnibus in California. And then of course, the ability for other states to adopt California's regulations without having to go through the US EPA. That combination of things is really, from a regulatory perspective, what I think is most important.
Wow, that sounds like California is the proving ground for bleeding edge technology.
Yeah, what's new in the last 30 years? It's pretty standard.
All right. Well, so from our audience, we have a question from Colin. How many fuel cell heavy duty vehicles currently operate in California, buses or anything else?
So the biggest count is actually light duty vehicles, right? So not heavy duty vehicles. You're basically looking at your Toyota Mirai, your Hyundai Nexo. There's still a few Honda Clarities out there, and there's several thousand of those. In the heavy duty space, most of the ones that are operating are transit buses. And like I said, I don't have the exact count. It's probably on the order of a dozen. I might be underselling the market a little bit, but I think that's probably about right. But then I mentioned these demonstrations from Hyzon and Toyota and Nikola and Hyundai. And over the next year or two, those demonstrations will probably cumulatively have 40 or 50 vehicles in the Class 8 category out there on the road.
Wow, that's a lot. Also from our audience, from Mike, you mentioned science-based roadmaps earlier. How do regulators' plans compare?
Yeah, so science-based targets are, as I said, they're predicated around asking the question, what do I have to do to reduce my emissions to align with the 1.5 degree C IPCC targets? In most cases, that answer is far more stringent than anything that's being required in the near term, right? Because that target is typically going to be like a 2030 or a 2040 goal. And you're probably looking at somewhere between 60 and 80% GHG reductions. And that exceeds even California's roadmaps. So to the extent that you see businesses chasing those SBT targets, they have a very steep hill to climb in front of them.
That's a lot coming forward at us. So you had mentioned a little bit about infrastructure. Let's talk about that. So we look at infrastructure of where we're getting stations, but the stations need to be fed by power coming from a power plant. So that local power grid support, some of these grids are kind of old. Cables might not have been sized or whatnot. So what's it going to be like charging an entire fleet overnight? Is it going to be like sucking molasses through a straw?
So the answer is it varies, right? And when you think about somebody who maybe just has a few sedans or pickups, each one of those vehicles might need 5 to 10 kilowatts. Now, for your house, that's basically like an air conditioner, maybe a couple air conditioners, right? So it's a lot for your house, but from a sort of an industrial facility perspective, a few of those types of vehicles isn't that big a deal. There may need to be some grid upgrades locally, upgrade your transformer or something like that on your site, but that's not the big challenge. Where we see the big challenge is when you look at the very high use vehicles, particularly the big heavy duty vehicles. If you look at a Class 8 truck of the type that are being commercialized, they're going to have 300 to 500 kilowatt hour battery packs. So that's 3 to 5 of the biggest Teslas you can get, right, in one vehicle. And that vehicle is going to operate 8, 10, 12, sometimes 18 hours a day. So they might require 1 to 2 charges a day. If you try to charge that vehicle overnight, you're looking at probably 50 to 100 kilowatts of load for a single vehicle. And, again, for rough numbers, that's maybe 25 to 100 houses to charge one vehicle. And yes, you're trying to charge that overnight, which hopefully avoids some of that grid congestion and helps avoid overloading the local infrastructure. But in many cases where these vehicles park, those facilities were never intended to bring multiple megawatts to that facility. So you do end up talking about regional transmission distribution analyses and utilities making investments at substations and distribution feeders and all of those sorts of things. And it's a place that we're seeing a lot of investment, a lot of planning from the utilities, trying to make sure that they're upgrading the grid in the areas where it's going to be needed. But no doubt there is going to need to be a lot of grid side and customer side investment in infrastructure for the expected electric vehicle deployments.
Wow, that's a broad view.
Cecilia, if I could follow up on that a little bit.
Yeah.
Not only do we need distribution, but especially here in California, we have brownouts just because we have a warm afternoon.
Yes.
If we add the load of transportation that's normally served by petroleum, where's the energy going to come from, even if we have the infrastructure to distribute it and the charging stations to plug into the vehicles? Is that being addressed at all at the regulatory or infrastructure level?
Yeah, so generation is what I would say is a down the road concern. It's not actually generation very often that's our challenge. It's getting the electricity from the point of generation into our neighborhoods. We have line congestion issues, right? Especially when it's that hot day and everybody's turning on their AC. The wires are hot, your resistance goes up because your wires are hot. You start getting all of these power quality issues as you're moving the electrons over a very long distance. We have, for various reasons, taken out certain generating infrastructure that helped balance the grid. And so while there's still available electrons, way out in the desert, that we could bring in, the grid wasn't designed or wasn't built up over the years to bring all of the power from those corridors, right? We had the Huntington generating station, we had San Onofre generating station. And as we've shut those down, we've really taxed the power transmission corridors. So that's a big problem. But there's another element here that I think gets kind of to what you're talking about as well. And that's that up until now, your electrical grid and your transportation systems reliability have been separate. The moment that you switch to an entirely electrified transportation system, your transportation is generally only as reliable as your grid. And so, I think no matter what the exact state of the grid is in any place today, there is going to have to be investment in strengthening the grid, providing for more resiliency and redundancy. And there's a lot of discussion about vehicle to grid technologies. How can you leverage those to help with this? Should we change the grid topology to these sort of interconnected meshes that can sort of self-heal, right? So that when a part goes down, when a transmission source goes down, the rest of the mesh can support itself. So there's a lot of interesting thinking going on here. In the short term, we just got to build more transformers, more wires, upgrade systems. That's the near-term answer, but there are a number of very interesting long-term strategies that are being developed.
Mike, great segue question. So on the flip side of local power grids, not just as a consumer or a customer for these fleets, can fleets be a temporary supplier in brownouts to avoid overheat and fire, especially in California, as sort of mentioned or alluded to in a news article earlier this week, PG&E, also known as Pacific Gas and Electric for those outside of California, announced that their latest round of bi-directional teaming, this time with GM. Previously, they did it with BMW. Patrick, what are your thoughts of these fleets as part of the vehicle to grid option in a brownout?
Yeah, that's vehicle to grid is a very promising technology. There's a lot of challenges with making it work reliably and understanding what all the incentives are for the market participants. The F-150 Lightning, which is now in production. Hopefully we'll see the first units delivered in the next, 6 months or so. It has its own vehicle to grid capability. The charge station that it supplies is capable of exporting, I believe it's 10 kilowatts, remembering correctly, back to your house, right? Now, to do that, there's a lot of requirements, right? It has to have a transfer switch and separate you. So it's not doing true vehicle to grid. What it's doing is what we call vehicle to infrastructure, right? It's supplying your home when the grid goes down. But with the right safety controls and whatnot in place, it's entirely possible it could do vehicle to grid. It needs a signal, right? It needs to know when it should be providing vehicle to grid. There has to be market incentives in place to make sure that it's worth your time and your effort here, if you will, to provide that service. And generally we think, well, there's no time or effort or cost to me to just let my vehicle export power. But you have to make sure your vehicle has the charge it needs when you're ready to go somewhere. But more importantly, you're cycling that battery, and cycling a battery wears that battery down. So there is a cost, right? So these sort of practical issues of how do you, organize the communication, how do you provide the right price signals, all of those sorts of things, I think are the real challenge. And there's been a number of vehicle to grid demonstrations in different utilities, trying to get at those specific questions, as well as sorting out all of the standards to make sure that that we do it safely. Right. The biggest concern with vehicle to grid is that a line goes down and the vehicle to grid technologies don't de-energize that line, and it creates a big safety issue. So there's a lot there. There's a lot of potential. I think you will see more and more people interested, the same way we see people interested in Tesla Powerwalls and things like that, of saying, how can I be resilient and redundant, independent of the grid, right? How can I have that capability? And, you got a battery electric truck, you have 130 plus kilowatt hours sitting in your driveway. So how can you use that, right? And so I think we'll see more and more of those sorts of projects in the short term.
Sounds like a lot of thought there. Great. So let's pivot to a different kind of infrastructure. The post office. So from our audience, Brent McCarthy asks, what is slowing down the Postal Service adoption of electrics for urban use?
So I'm going to try to dodge the political landmines associated with this question.
Purely from engineering standpoint.
Yeah. There are some legitimate challenges, right? The post office faces. If you think about the service territory and the range of places the Postal Service has to cover, right? There are a lot of rural post offices and vehicle services. Those vehicles need to, they're specialty vehicles. They have limited sizes and shapes. They have to serve all of these different terrains. And I think that has been one of the considerations that said, well, let's ease into battery electric. Let's do it in some sectors, but let's have the comfort and redundancy and additional capability afforded by hybrid technologies for a significant portion of our fleet. That's where I think the thinking lies. I think there's plenty of room for debate about how much that hybrid share should be of the fleet.
Great, thanks. So speaking of fleet and trends being changes over time, we're going to look backwards and forwards. So do diesel engines have a future in commercial fleets in the coming decade?
They definitely have a future. I think the question is whether it's a growing or dwindling future. And I have to say, I don't see diesel market share doing anything but declining. Now, whether that's going to collapse or whether that's going to be whittled away slowly as these other technologies get through their own growth pains, fundamentally, as I talked about with all these regulations, it is becoming harder and harder to build an engine that meets regulations. It's becoming more and more expensive to produce and operate that engine. So at some point, these other technologies catch up with diesel on a TCO basis, and they're compliant with all of these regs. And, short of the few applications where you just can't make any of those other technologies work, I think we have to recognize that at least traditional diesel and traditional gasoline are on a downward trajectory over the next 10, 15 years.
Wow. Patrick, in your presentation, you covered quite a few fuels, different energy sources. From our audience, Brian Miller asks a two-part question. What are top challenges for hydrogen adoption for freight operations? And what are the opportunities and timelines to overcome?
So we talked a little bit about some of the challenges around hydrogen in that little mini brief. From my perspective, we obviously need more vehicles out there, right? We don't have much in the way of commercial vehicles at this point. I think they're very close to getting to commercialization. There's a lot of good learnings and experience from the light duty side of the world. But applying those to the heavy duty space and in the commercial fleet space and making sure that they can live up to the endurance, reliability, bring down cost, et cetera, that's a challenge. Again, I think we're moving along there. The real challenge in my mind is fuel cost and fuel availability. If you look at the retail price of hydrogen today, it's somewhere between $10 and $15 a kilogram. On a gasoline equivalent basis, that's maybe $7, $8, $10 a gallon equivalent. Now, 2 months ago, you might have thought that's crazy. We're now paying $5 to $6 a gallon for gasoline in this environment. So maybe it's not as crazy as you'd think, but it's certainly too high. And that price is in light duty market. It's somewhat artificial because it's supported by a number of manufacturers providing fuel card incentives. Again, it's early generation technology for the stations. But the reality is we have to increase volume. The fuel economics are largely driven by scale. So, that I think we need to see that come down. The good news, I think, with heavy duty is that they tend to demand a lot of fuel. And so making progress in heavy duty is going to accelerate that scale that you need to achieve to bring those fuel costs down.
Good points. Kind of going along the lines of regarding fuel, kind of a spin on diesel, anonymous from our audience. Question about the public can easily confuse concepts like renewable diesel versus biodiesel. How is that being addressed in educating fleet managers?
Biodiesel versus renewable diesel?
Yes.
That's an interesting question. And generally fleet managers just sort of ask the question, right? Or start with, I tried biodiesel and it didn't work out for me. It caused all of these problems, right? There is a tremendous amount of new renewable diesel production coming online. Marathon, Phillips 66, and others are starting up new RD specific refineries. And I think the market's sort of taking care of educating the fleets, right? They need to sell this fuel. They're making the calls. They're, getting fleets together and asking them and trying to explain the differences here. I'll also say, sort of self-promotionally here, things like ACT Expo are where a lot of these fleets come and say, people keep throwing these terms at me. I don't know what they mean. Help me figure out what's really going on. So it's that coming together of the peers, but also, the natural sales cycle that we're seeing emerge from RD that's really driving a lot more effort into trying to educate fleets about RD. Because at the end of the day, it is probably the single easiest, not always the single cheapest, but certainly the single easiest thing a lot of fleets can do to immediately reduce their GHG emissions.
Just as an aside, as a former energy engineer, it makes me wonder at what point we'll start measuring the price of energy as dollars per million BTU instead of per gallon.
Yeah, I hope we do it per megajoule because.
Oh, sorry.
Fair
Fair enough.
Yeah.
All right.
Yeah.
One more from our audience, kind of an encompassing one. So from Neil, we have a two-parter. Which clean technologies do you have optimism for? And predictions for which technologies will dominate in the next 5 to 10 years?
That is a tough one. I mean, I have optimism for all of the technologies because they all have strengths and they all have weaknesses. So, I know that there is people have adopted certain phrases like electrify everything as the answer, right? I've long believed that, to be a little, trite about this, there's no silver bullet, there's only silver buckshot, right? We need multiple solutions. And some of them may not pan out. We may look back 20 years from now and say, boy, we really wasted our time on that technology. But the reality is, if you look at climate change as a serious threat to this planet, or at least our comfortable life on this planet, it's worth investing in multiple solutions just to make sure you don't find at the end of the day, you don't have the solution you need. So I think for that reason, over the next 5 to 10 years, there's going to be growth in all of these technologies. I think zero emission is really important in certain places. So if we're thinking about California, I think you have to ask yourself, what is going to be my zero emission strategy? You may not have to have it today, but at some point you're going to have to get there. So I think the zero emission technologies are going to see the most sort of growth on a percentage basis, if you will, over the next 10 years in places like California.
The relativity factor. Great.
Yeah. Yep.
Well, that wraps up our Q&A. Any final words of wisdom for us before I pass it off to Mr. Mike for SAE comments?
No, I just really appreciate the time, the interest in the space. Look forward to meeting any of you in person if you're able to come out to ACT Expo. And again, if you're interested in the 2022 version of the report, please feel free to head over to sustainablefleets.com or stateofsustainablefleets.com and download the 2022 version in May.
Fantastic. So see everyone at ACT Expo in May. And now we'll turn it over to Mike.
Cecilia, thank you. And Patrick, great presentation. I really appreciate it. And I did actually have one follow-up question if you're still there. Do you do anything?
I am.
You're focused exclusively on ground transportation, or do you do anything with aircraft fleets?
Yeah, so we had for a while a conference called High Horsepower, and it was focused on marine, rail, mine haul, a lot of those really big high horsepower applications where they just weren't being talked about, but have tremendous opportunity from an economic perspective because of the amount of fuel that they consume. Aircraft is certainly in that. Aircraft has its own challenges, obviously, right? We all can sort of think about about weight as the issue, right? So we've done some in those spaces. We see a lot of interest in trying to electrify aircraft. We also see some companies that are now looking at hydrogen for sort of short to medium haul air transport. So even in those categories where I think maybe 10 years ago we would have said, boy, aircraft are going to be the last thing to go. We are seeing some growth and interest there, and I think we'll see some more zero emission demonstrations in the next couple of years.
Great. I'll use that as our segue to the SAE Aero Design Collegiate Competition. We do need volunteers for that. So if anybody is interested in aero design, please get in touch with our student activities or other members on the board to help out. And also on ACT, which is just before the SAE, I'm sorry, in May, here in Long Beach. So it is a local event. There are discounts for SAE members for that event. So I've been to it in the past. It's pretty impressive to see the heavy duty technologies. So if you're interested in car stuff, the big truck stuff is pretty astounding as well. So definitely check it out. Looking forward to seeing everybody at our upcoming events and starting to get back to in-person events at SEMA. Should be a great opportunity to meet people that you've been seeing online and seeing questions from and find out who we all are. So I hope you'll join us at all of these events and really appreciate Cecilia and Patrick for a great meeting. Thank you.